You've spent months learning to code. You finally land a technical interview at a company you've been dreaming about. You sit down, the interviewer shares their screen and types out a problem. Your mind goes completely blank. That moment happens to thousands of developers every single year. And here's the brutal truth. It's not always about who's the smartest in the room. It's about who's the most prepared. In 2026, coding interviews have evolved. Companies aren't just testing if you can write code. They're testing how you think, how you problem solve, and whether you understand the core patterns that show up again and again across every major tech company, from Google to Amazon to the hottest AI startups. So in this video, I'm going to break down the top 5 coding interview questions you absolutely must know in 2026, with real examples, clear explanations, and tips that even beginners can follow. Whether you're a student, a career switcher, or someone who just wants to finally crack that technical round, this video is for you. Let's get into it. Introduction. Now, before we dive in, here's what you're going to walk away with today. You'll understand the 5 most important coding question patterns that interviewers are obsessed with right now. You'll see how to actually approach them, step by step, not just memorize solutions. And you'll get practical tips on how to practice so that when you walk into that interview, you feel confident instead of scared. These aren't random questions. They're based on what companies like Meta, Google, Microsoft, and fast-growing tech startups are consistently asking in 2025 and going into 2026. Let's start with number 1. All right, the first question is called to sum, and if you've done any interview prep at all, you've probably heard of it. But here's the thing. Most people think it's too easy and skip over it. Big mistake. The problem is simple. Given a list of numbers and a target value, find 2 numbers in the list that add up to the target and return their positions. For example, if your list is 2, 7, 11, 15, and your target is 9, the answer is position 0 and 1 because 2 plus 7 equals 9. Now a beginner might loop through every pair of numbers to check this. That works, but it's slow. What interviewers really want to see is the hash map approach. As you go through the list, you store each number in a dictionary. For each new number, you check if the difference between the target and that number already exists in your dictionary. If it does, boom, you found your pair. This runs in linear time, which means it's fast even for huge lists. Why does this matter in 2026? Because companies use this exact pattern to see if you understand time complexity and data structures. It's not just about solving it. It's about solving it efficiently. Practice this until it becomes second nature. Moving on to number 2. Valid parentheses. This one looks simple on the surface, but catches so many candidates off guard. The problem: given a string containing only brackets, like parentheses, square brackets, and curly braces, determine if the string is valid. A string is valid if every opening bracket has a matching closing bracket in the right order. So, os is valid, but i nakom is not. The key to solving this is a data structure called a stack. Think of a stack like a pile of plates. You can add a plate on top and remove the top plate. Every time you see an opening bracket, you push it onto the stack. Every time you see a closing bracket, you check if the top of the stack is its matching opener. If it is, pop it off. If it isn't, the string is invalid. This question is beloved by interviewers because it tests whether you understand stacks and can translate a real-world rule. Things must close in the right order, into clean code. In 2026, with so many developers building parsing tools, compilers, and AI code assistants, this concept is more relevant than ever. Master the stack, and you unlock a whole family of similar problems. Question 3 is binary search. And this one separates the candidates who truly understand algorithms from those who don't. Here's the scenario. You have a sorted list of numbers, and you need to find a specific target. A beginner checks every item one by one. That's fine for small lists. But what if the list has 1 million items? Binary search cuts the problem in half every single step. Here's how it works. You start by looking at the middle element of the list. If that element is your target, great, you're done. If your target is smaller, you search only the left half. If your target is bigger, you search only the right half. You keep having the search space until you find what you're looking for or determine it doesn't exist. For practical context, think about how search engines, databases, and recommendation systems retrieve information instantly from billions of records. Binary search is baked into the foundation of those systems. In interviews, this question tests your understanding of divide and conquer thinking, one of the most powerful patterns in all of computer science. Learn it, visualize it, and practice writing it from scratch without looking it up. Number 4 is reversing a linked list. Now I know what you're thinking. Isn't this old? It is. And it's still on almost every technical interview in 2026. Because it's not just a question about linked lists. It's a question about pointers, memory, and how you handle things that don't have an obvious index like arrays do. A linked list is a chain of nodes. Each node holds a value and a pointer to the next node. To reverse it, you need to flip all those pointers so the last node becomes the first. The trick is to use 3 variables: a previous node, a current node, and a next node. As you walk through the list, you temporarily save the next node. Point the current node backward to the previous one, then move everything forward. You repeat this until you've flipped the entire chain. This question shows up everywhere because it perfectly tests logical thinking and your comfort with managing state as you move through data. It's also a foundation for more complex graph and tree problems, which leads us perfectly into question 5. And here we are, question 5. And this is the one that levels you up from beginner to competitive candidate. Breadth first search and depth first search, or BFS and DFS, on trees and graphs. In 2026, with companies building social networks, knowledge graphs, AI agents that navigate decision trees, and route optimization systems, graph traversal is everywhere. BFS explores a structure level by level, starting from a root and visiting all neighbors before going deeper. DFS, on the other hand, goes as deep as possible down one path before backtracking. Here's a simple way to remember it. BFS uses a queue, first in, first out. DFS uses a stack, or recursion. For a binary tree, DFS with recursion looks like this. Visit the current node, then recursively visit the left subtree, then the right subtree. That's it. Real-world use case? Think about finding the shortest path between 2 users on LinkedIn, or how a GPS finds your route. BFS, or how a file system explores nested folders. DFS. Interviewers love these because they reveal how you think about complex interconnected systems. Practice drawing these algorithms out on paper before you code them. Visualization is your best friend. So let's do a quick recap of what we covered today. 2Sum taught you hash maps and time efficiency. Valid parentheses introduced the power of stacks. Binary search showed you divide and conquer thinking. Reversing a linked list built your pointer logic. And BFS and DFS gave you the tools to navigate complex graphs and trees like a pro. These 5 patterns will cover a massive percentage of what you'll face in real technical interviews in 2026. You don't need to know everything. You need to know the right things, deeply and confidently. If you found this video helpful, do me a favor. Hit the like button right now. It genuinely helps this channel reach more people who are trying to break into tech. And if you want to keep leveling up your coding skills, subscribe and turn on notifications because we drop new content every week on AI, programming, automation, and everything you need to build a real tech career. I'll see you in the next one. Keep building, keep learning. You've got this.